Hey everyone! Welcome back to the channel. Today we're diving into a classic but crucial topic in networking, collision domains. Whether you're just starting out or brushing up for your next cert, this video will make it crystal clear. Collision domains. To understand what a collision domain is, we have to look a little bit in the past when Ethernet LANs were built using devices like hubs and bridges. Ethernet LAN with hubs Ethernet hub is a network device that is used for connecting multiple nodes and making them act as connected to a single network segment. It works purely at the physical layer of the OSI model. It has multiple ports in which the incoming electrical signals on one port are repeated at the output of every other port. There is no forwarding logic at all. A hub makes all connected devices to be part of one single network segment because every electrical signal on every cable is replicated to all other cables. This creates a single shared medium, and a network collision occurs when more than one device attempts to send a frame on the segment at the same time. Figure 1 shows an example of two PCs trying to send an Ethernet frame simultaneously. Because they are connected to a shared network segment, they are part of one collision domain. It is also visible in Figure 2 that only one of the PCs in the collision domain may transmit at any one time, otherwise collision occurs. Carrier sense. Multiple access with collision detection, CSMA CD. When a device wants to transmit a frame, it checks to see if the segment is free. If the segment is not free, the device waits a random amount of time before retransmitting. If the network segment is free and two devices send frames at the same time, their signals collide. When the collision is detected, they both stop and wait a random amount of time before retransmitting. To understand what is behind carrier sense multiple access, with collision avoidance, let's look at each component individually. Carrier sense, CA. The idea that nodes may only send data over the network if the shared medium is free. Multiple access, MA. Several nodes share a network segment, so they need an access method to resolve collisions. Collision detection, CD. If a collision does occur, it will be detected, and the transmission will be tried again, after a random amount of time. The concept of collision domains applies also in wireless networks, because the radio signals traverse a shared medium, which is the Wi-Fi radio spectrum. So all things we have said by now apply to wireless networks as well. Only one node in a wireless LAN may transmit at any one time, otherwise collision occurs, as shown in Figure 3. Several techniques were introduced over the year to resolve this scaling problem. For now, we are going to focus only on the wired LANs. Ethernet bridges. Ethernet bridges are the predecessor of modern LAN switches. They were introduced to resolve the scaling problem with shared segments and collisions. Bridges are Layer 2 devices, which means they can read the Ethernet header of the frames they forward and take decisions based on the information in the headers. This eliminated the need to send all frames out all ports, which practically means to repeat all electrical signals out to all ports. Therefore, Ethernet bridges split a network segment into two collision domains, as shown in Figure 4. At the time, that was a huge scaling improvement and enabled the creation of larger LAN segments. As local area networks grew bigger, demand for more scale was needed, so devices with better performance and more interfaces were introduced. LAN switches, Ethernet switches, LAN switches completely resolve the problem with collisions. They operate at Layer 2 of the OSI model, meaning that they look at the Ethernet header and trailer. Their main advantage is that all their ports can operate in full-duplex, meaning they can simultaneously transmit and receive frames on any given port at any given time. Because of this, the media access algorithm for collision detection, CSMA, CD, is no longer required and is disabled by default. Another big advantage of switches is that they forward frames based on MAC addresses, so any given frame doesn't need to be sent to all ports as hubs do. That's why these days, all wired local area networks are built with LAN switches. Troubleshooting collisions, Cisco switches have pretty sophisticated interface statistics that are sufficient for troubleshooting problems. In Ethernet collision domains, there are a few counters we have to check out. Deferred frames. The deferred counter increases when the switch tries to send a frame out an interface but found the carrier busy. Carrier sense. This does not mean that there is a problem and is part of the normal Ethernet switching and forwarding process. Note the example. Collisions. It counts the number of collisions that occurred after the frame was sent by the switch. Check the example. As explained above, it is normal to have some collisions in the network, but if the number is high, it might indicate that the collision domain is too big and must be broken down into smaller ones. Late collisions. If a collision is detected after the first 512 bits of the frame was sent, it is counted as a late collision. It usually points to a duplex mismatch, incorrect cabling, or that the collision domain is too big. Summary. So in summary, the most important points about collision domains are: all devices connected to a hub are into a single collision domain. When devices are into a single collision domain, they must use half-duplex communication. They either transmit or receive frames at any given time, but not both. Only one device may transmit into the collision domain at any one time, otherwise collision occurs. The other devices detect the transition with the CSMA CD method, wait a random amount of time, and retransmit again. Each switch interface is a separate collision domain. Each switch interface can transmit and receive frames at the same time. Full-duplex .CSMAI CD is disabled by default on switches because collisions cannot occur. Thanks for watching. If this helped you out, give it a thumbs up and subscribe for more deep dives into networking concepts. Stay curious, stay connected, and I'll catch you in the next one.